Okay, now let's see how we can convert the 2D optimization graph into a 3D model using the Abaqus software. So when you open Abaqus, so this will be the default interface. And then we are choosing the with standard and the explicit model. So so before we move on, I give you a brief introduction to the interface of the Abacus. Roughly, I think, as mentioned in the lecture, we are going to consider this finite element tool as a black box as well. So for this interface, similarly, there will be some menus, and then if you click it, it will pop up lots of different quick access comments, and then this will be a quick access bars for different tools. So commonly we are going to use these wheels. This we operate in the files and then adjust the windows and then fit into the wheel, etc. So there's other tools. Gradually with the cost going, I'm going to introduce more tools for you. So for the this graded blue area, dark blue area, will be what we are visualization part. What we build in the model will be shown here. So at this part is a model database. That is all the you define things will can be found from here. And the bottom there will be we call it output window. So there are also a command window, this output window. So when you do some operations, and then you can see some change over there, give you an update or summarize what you did there. And then also at the bottom, you see this similar all along this line. Sometimes when you require some input or intervention or some tips, you can find along this region. Okay, I think that's all for the Abacus interface. Now we move on to our problem. So as I mentioned, we have already obtained a graph like this one. So roughly, sometimes if you save it directly from the MATLAB, probably it may be bigger. The image may be big, too big for the Abacus in my desktop to use. So I'm going to change the size. So very simple. What I need is this graph, and then I'm going to resize it. So image resize, and then I will save it 50% of original. I think that's usually for most of cases I will save it and then it should be fine. Now we go back and now we are going to use the parts. By default is in the part module. So in part, I'm going to all the way down to the first icon there, create a part. So we can give it a name is CB, cantilever beam, optimization, optimal design 01, the first optimization design. We are going to make a 3D now, and then roughly solid, and then we'll give it an approximate size. As mentioned, it's let's say the total length and height will be 400 millimeter, right? So I will double that, so roughly 800 millimeter. I will make it round to 1 meter. So I will set one there. Okay, now we'll enter into this interface we call it sketch interface, which is you can't see it from this module. Actually, it's here on the bottom. So this will be the sketch part. Um, so in there, okay move all the way down to the bottom. You see there's two icons on the bottom. We call it sketcher option and the reset views. So what we are going to do is we use the sketcher option. So from the sketcher option, we will get the roughly some settings. To use image, we directly switch to the image type. So first one, dimension constraint image there, and then click show image. Currently there's nothing there. We need to create one. So file name, we will wait file name, and then we will click this one, select the image. At the bottom, there's a select image. Click it, and then we need to navigate this to the folder contains our image. So I think my one is in here. A little bit more. TU1. Oh, sorry. TU1, and then that will be it. So remember we resize this one and press OK. So it's a set invalid name. This means it's because the name here you can't have a dot in there. I need to delete this dot, or I change the dot with a D. So that will be a valid name. OK. Now I can press apply. So you will see a white area showing on your screen. So what you need to do, you are going to use this auto fit wheel. Auto fit wheel. And then probably you can using this zoom. Wow, that is very, very big because he will consider pixels as meters. So this very big. And then you can see it. Now we need to calibrate. We need to tell Abaqus. So what's the real size showing on your image? So what you need to do is actually you need to like recenter it and then choose 2 points with known sizes. We know from there to there, we know the total length is 400 millimeter. So we'll go to the calculate the scale. We use calibrate. See this calibrate, click calibrate. So you can see here it is a peak calibration point 1. If you click this point, and then if you notice the peak calibration point 2, and then you click the other end. And then you will tell the distance between calibration points. So distance we know is 0.4 meters. So by default, I prefer Abaqus to use meter as the default length unit. Um, so of course you can use other units, but I think in future I will talk about how you can use a consistent unit in Abaqus. So we use meter for now. And then if we apply, uh, oh, and then here we enter, sorry, we click enter. And then you can see your image will become very small. And then now these two, auto fit will be useful. And then if you screen or use this one again, and then you can get this image now is in real size. Uh, Next one, usually we need to place, let's see, this corner as the origin. You can pick the origin. So I will enlarge that, pick that point as the origin. So I will move it back. You can see this will be the origin. Um, so now, next one, we are going to use line tool to draw these lines, the circumferences of the whole model. So I'm going to draw the line first. So let's start from there, and then end with there, go down. This part is curved. Probably I will use a different tool later on. So I will cancel the current procedure. You can directly click cancel procedure. Now you are going to use uh, line tool to continue for other parts. So from there to there, if you see this very close to a line, and then you can directly using a line tool to represent it. So if you see it's more like a curve, and then you can use a curve to represent it. So I think inside is more like a line. I still using line tool. to draw that parts. So if you find some like errors, and then you can always use this undo parts, and then you will click this and then continue to do it more accurately. Yeah, roughly. I think that's cancel the current procedure. The last one, this line is a this like edge is a curve, so we are going to use this curved line, create a spline, we call it, through points. And then we will click here, roughly go there, and then go to the other end, and then press down. So that's all the outline, and then I cancel the current procedure, and then press down. He will ask what's the thickness. The thickness is actually, as I mentioned, is 50 millimeter. So that's 0.05 meter, and then press OK. Now we get an 3D optimal structure.